Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3, so I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3 which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation. Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x on my left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. From here, I'm going to divide both sides by 3. So these two cancel out, and I get 9 to the power of x is equal to 999 divided by 3, which is 333. Alright, so from here, I'm going to take the log on both sides. So I get log 9 to the power of x is equal to log 333. And if I have something in the form log a to the power of b, this is equal to b times log a. So log 9 to the power of x, I can move the x to the front. So I get x times log 9, which is equal to log 333. From here, I'm going to divide both sides by log 9 because we obviously want to isolate x. So these two cancel out, and I get x is equal to log of 333 over log 9. Now, I can rewrite log of 333 as log of 3 times 111. And I can rewrite log of 9 as log of 3 squared. Now, we know that if I have something in the form log a to the power of b, I can move b to the front. Another property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So I get x is equal to log 3 plus log 111 over 2 times log 3. And this is equal to log of 3 over 2 times log 3 plus log of 111 over 2 times log 3. So now these two cancel out, and I get x is equal to 1/2 plus log of 111 over 2 times 3, log 3. So now log of 111 is equal to 2.045. So I get x is equal to 1/2 plus 2.045 over 2 times log 3. And log 3 now is equal to 0.301. So I get x is equal to 1/2 plus 2.045 over 2 times 0.301, which is 0.602. So now log of 111, which is 2.05, divided by 0.602 is equal to 3.397, which is the same thing as 3.40. So if I add 1/2 to this, I get 3.90 as my solution